Welcome, dear learners. I, Dr. Neelam Yadav, Assistant Professor at ABES Engineering College. I'm presenting this lecture video on engineering chemistry. The topic of this lecture video is plastics. Here, the contents which I will be covering are types of plastics. The two major types of plastics which I'll be discussing over here are thermoplastics and thermosetics. With examples of thermoplastics, which I'll be including in this topic is polythene, polymethyl methacrylate, and polytetrafluoroethylene. And under the thermosetting plastics, I'll be discussing about bakelite. Now, before starting with the plastics, I'll be introducing it to all of you. This plastic term is derived from a Greek word which is termed as plastikos, which means to mold. The plastics were discovered by German chemist Christian Skobin in 1846. What exactly plastics are? These are polymers which can be shaped into hard and tough utility articles. These are some of the polymers which can be shaped into hard and tough utility articles which are being used in the market nowadays. And we are very much aware that most of the things surrounding us are involving plastic. And polymers under heat and pressure get converted into plastic. They're termed as plastic because during their processing or manufacturing stage, these polymers have a condition which is termed as plastic. So the generated products are called as plastic. Now, different types of plastics. These are thermoplastics and thermosets. Thermoplastics are long chain linear polymers. Since they are linear polymers, they are not having cross linking between them, and the properties which they have, those are temporary in properties. Most important part of the thermoplastic is they can be softened on heating and hardened on cooling. And this process can be done reversible. That means if a thermoplastic is manufactured and molded into certain type of article, this can further be again recycled or reused by remolding it again. Now, thermosettings are the polymers which are having cross-linking between the layers. When the cross-linking exists between the layers, the properties of the polymers is converted into permanent settings. So whatever properties are obtained by this thermosetting polymers, these are permanent. And once they are molded, they get, and when cooled, they are hardened, but then they cannot be remolded. That is, they cannot be reused. Now, starting with the thermoplastics, we will be taking some of the examples of thermoplastics, that is PE, PMMA, and Teflon. These thermoplastics are also known by different names, which I will be discussing in coming slides. What is polyethylene? Polyethylene are, in market, it is visible in this form. And polyethylene are of two varieties. One is low density polyethylene and the other one is high density poly. Basically, the manufacturing or preparation process of these two polyethylene varies. In low density polyethylene, the preparation is carried out under high pressure. That is, when we prepare low density polyethylene, the pressure is to be maintained at 1000 to 5000 atmospheric pressure, and the temperature is also high, that is taken as 350 degrees centigrade. In presence of a catalyst, the catalyst used over here is an oxide initiator, and this catalyst helps in converting the ethylene molecules into polyethylene, and that too the polyethylene will be of the property of low density polyethylene. What are the major properties of this low density polyethylene? They are branched polymers. And so their crystallinity is very low. LDP is also flexible material, and its melting point is approximately 110 degrees centigrade. The major applications of LDP are packaging films. They are used in grocery bags, wire and cable insulators, squeeze bottles, toys. These are some of the applications of lower density polyethylene. This picture denotes the recycling code of LDPE. So the recycling code for low density polyethylene is this is the code for recycling code for low density polyethylene. Next, we are coming to high density polyethylene. Now here the manufacturing process, during this manufacturing process of high density polyethylene, low temperature is maintained and at low pressure. This occurs at low pressure. Here catalyst used is Ziegler-Natta catalyst. So when ethylene molecules undergo preparation for high density polyethylene, the temperature is to be maintained at lower temperature and pressure is also maintained at lower temperature. And the catalyst here used is Ziegler-Natta catalyst, which results in the formation of HDPE. This is high density polyethylene. Now the properties of high density polyethylene is these are linear polymers and show high crystallinity. The density is also very high and the melting point is approximately 144 degree centigrade, that is higher to the LDP. Now the applications of these high density polyethylene. Okay, now here the applications of high density polyethylene basically depends upon the preparation method which is being used to make this high density polyethylene. When the process used for preparation of this polymer is blow molding, then in that case, the polymer which we receive or HDP which we receive, that can be used for making bottles for the milk. However, other uses of high density polyethylene, they are used in household cleaners. When this polymer is made by blow extrusion method, the polymer which is generated, that can be used in the application of grocery bags. HDP is also used in construction films. This is the recycling code for HDPE, and these are some of the figures which are showing how we can use HDPE in our daily use. Now, next thermoplastic, which I'll be discussing over here, is polymethyl methacrylate, which is also termed as PMMA, polymethylene methacrylate. The other name for this polymethyl methacrylate is lucite. It is also called as Perpex and plexiglass. Because it has a property of somewhat property comparable to a glass, so the term plexiglass is also given to this PMMA. The preparation of PMMA is done by using methyl methacrylate as a monomer unit. These are the monomers which are being used to make the polymer polymethyl methacrylate. This polymethyl methacrylate is made in the presence of acetyl peroxide or hydrogen peroxide as a catalyst. And the process which is followed for making this polymer is addition polymerization mechanism. So this is the structure of monomer, methyl methacrylate, and this by using the mechanism of addition polymerization in the presence of hydrogen peroxide or acetyl peroxide as catalyst, it makes the polymer which is called as polymethyl methacrylate. The structure denotes this is n number of methyl methacrylates monomer which is being repeatedly added to this polymer and results in the polymethyl methacrylate. Now the properties of polymethyl methacrylate are, it is amorphous in nature, colorless, transparent thermoplastics. Due to the presence of methyl group as substituents, this polymer shows restricted flexibility. Due to the presence of this methyl group, the polymer is having restricted flexibility. This polymer is also an excellent weather ability, shows excellent weather ability, weather resistant hai. And this PMMA, actually this PMMA, as I have discussed earlier, it is also termed as plexiglass. So this can be used in place of glasses, and they can be easily remolded and shaped into desired conditions. Whichever condition or whichever shape we need for this particular PMMA, we can shape it into this. The various applications of PMMA are, it can be used in motorcycle windscreen. This can be used in wash basins. These are used for optical fibers. These are used in light fittings, generally for street street lamps, housing, factories, etc. These are also used in ceiling lightning at schools, rooms, factories, different other different areas. This is also used to make the bubble body of many helicopters. These are some of the basic applications of plexiglass, or we can say perspex, or polymethyl methacrylate, or lucite. Now, next thermoplastics, which we will be discussing over here, is polytetrafluoroethyl. The short form for this is PTFE. It is also known as Teflon and Fluon. Here, monomer used is tetrafluoroethylene. This is the monomer which is being used, and this monomer in the presence of a catalyst. The catalyst being used over here is benzoyl peroxide. In presence of this catalyst and under high pressure, this monomer gets converted into a polymer which is termed as Teflon or Fluon as well. Now, the properties of this Teflon is it is high density polymer. It has high toughness and high heat resistance. That's why it is used in cookwares as a coating. These are chemically inert over wide temperature range. They have excellent electrical insulation, and they are also non-adhesive. Different applications of Teflon are coatings of frying pans, non-lubricant bearings, fire and cable insulations. They are also used in seals and gaskets. They are used in packing valves, pump parts. They are used in stopcocks for burette that is used in chemistry labs. And other uses of this Teflon is they are used as insulators for generators and also used as a capacitors. Now, next discussion which will be done over here is an example of thermosetting plastics. Thermosetting plastics are those plastics which cannot be remolded once they are hardened and cooled to a desired shape. Now, the example of this thermosetting plastic is bakelite. It is also known as phenol formaldehyde resin or phenoplast. Since this is formed by condensation polymerization, also the monomers being used over here are phenol and formaldehyde. So when we are manufacturing bakelite, the monomers which are being used is one is we use phenol and the other one is formaldehyde. And these phenol and formaldehyde initially is reacted in an acidic medium to form two products. They yield two products. One is ortho and the other is para-hydroxymethyl phenol. These ortho and para-hydroxymethyl phenol, these are further polymerized by condensation polymerization, which results in the formation of a bakelite. Majorly, the component which we use for making the bakelite is ortho-hydroxymethyl phenol, which undergoes condensation polymerization, which results in initial formation of a linear chain, which is termed as novolac. And this novolac further reacts with formaldehyde to form a cross-linked product, which is called as bakelite. This is the structure of bakelite, and it is a thermosetting plastic. Now, the properties of bakelite are it is dark colored pinkish brown. It is hard, it is rigid and a strong material. It has good heat and moisture resistance. It has good chemical resistance. It has good abrasion resistance as well. It is having a good electrical insulator. It can be used as an insulation. It has excellent bonding strength and shows adhesive properties. Now, the applications, depending upon the properties of the bakelite, the applications are, it can be used for plugs and switches. It is used for the handles of cookers, saucepans. It can be used as adhesives for grinding wheels. It is used as varnishes, painting, protective coatings, and electrical insulations. Now, these are some of the references for this lecture video. Thank you.